Hello everyone and welcome back to your YouTube channel. And welcome to this very interesting video today. And today I prepare a very short video. Some of you will be probably interested because this is a very basic video. It's a video related to the topic introduction of power system and economics. As you must be aware, electrical power systems, they are very complex in terms of the size of the problem. Power systems tend to be very large, large numbers of bus bars, transmission lines, and so on. And for that reason, the best way to represent the power system is using matrices. And one of them, the admittance matrix model, is perhaps the most used model for power system representation. In this direction, power system operation and economics require many times to use the admittance matrix. And this video today is dedicated to present a very practical but extremely simple example related to the admittance matrix model. And without further delay, let me start with this video. Consider a very simple power system as shown in the single line diagram below. Here we have figure Q1, and there is a single line diagram of a very simple radial feeder. As you can see, there is a generator G1 connected to the bus bar number 1. This generator is providing active and reactive power to a very specific load located at the bus bar number 2. And the power flow is moving through this transmission line over here. And as you can see, there is a numerical value, and that numerical value is the physical admittance of this very specific transmission line. Now, what we want to do is to build the bus admittance matrix of the power system that is shown in the figure Q1. Well, let's start the solution. To be honest, the solution is extremely simple. All my students know that this system has two bus bars. And the matrix representation, in this case, the bus admittance matrix, is a square matrix. And the number of rows and columns of this matrix is equal to the number of bus bar. What I'm telling you is that this square matrix representing the admittance matrix is a 2 by 2 matrix. Inside there are 4 elements, as you can see over here. We are using capital letter to represent each one of the elements inside the admittance matrix. And as you can see here in figure Q1, we are using lower letters to represent the physical admittance in the real power system. Well, as you must be aware, there are many good power system books where you can find these two very important equations. In these two equations, what we are doing is presenting the way to calculate each one of the elements inside the admittance matrix. Here, as you can see, if I is not equal to k, we are outside the main diagonal of this matrix, and you can see that the elements of the admittance matrix is minus the physical admittance connecting the bus bar I and k. And the next term inside the equation that is here below, as you can see, is YII, because in this case, those represent the elements in the main diagonal, of the admittance matrix, and is basically the sum of all the physical admittance connected to the node I or bus bar I. Well, if we use those equations, building the admittance matrix is just a substitution work. What I'm telling you is that the admittance matrix can be rewritten in terms of the system elements or physical admittance. And as you can see over here, the 2 by 2 admittance matrix of this system is basically having the same element here in the main diagonal, and that is the positive value of the admittance connecting busbar 1 and 2. And outside the diagonal, we have minus the admittance connecting the busbar 1 and 2. This is very, very simple. Now it's just a question of substituting the numerical values. Here at the top, you can see that I have the admittance matrix, but in this case, I am presenting the rectangular form. And as you can see, the main diagonal, we have here two elements, minus 10j and minus 10j. And the elements outside the main diagonal, you can see that this is a positive 10j and this is a positive 10j. If we use the polar form, you must remember that when we are using the polar representation, we have a module and a magnitude. In this case, the elements in the main diagonal, they have the same magnitude, the number 10, and the angle is minus 19 degrees. And over here, we have the elements outside the diagonal, in this case 10, and the angle is 90 or 90 degrees. Well, this is the numerical examination, calculating element by element the admittance matrix of this very simple radial feeder. But what we want to do now is to show you that those numerical values are properly calculated. And what I will do now is use circuit analysis to show you that the matrix is properly calculated. Well, it's extremely clear for my students that the admittance matrix is coming from the Kirchhoff law. The Kirchhoff current law can be used to specify or to obtain the equivalent admittance model of any circuit. In this case, we are substituting here, we have the single line diagram, but now I am using more circuit-oriented representation. As you can see over here, we are assuming that the current I1 and the current I2, both of them, they are going into the circuit. And we have here the voltage V1 and the voltage V2, and connecting the bus bar number 1 and 2, we have the physical admittance 1, 2. Now it's just a circuit analysis exercise. We can apply the Kirchhoff current law, and for the node number 1, we can see over here that the current that is going into the bus bar number 1 will be identical to the current moving from 1 to 2. And using circuit analysis, well, we can say that that current 1, 2 will be the admittance 1, 2 multiplied by the difference between the voltage V1 and V2. And voila, we have the equation for the node 1. We can do similar analysis. We can do a similar analysis for the current I2. The current I2 is going into the node 2 and must be numerically equal to the current moving from 2 to 1. So the current moving between 2 and 1 is the admittance Y12 multiplied by the difference between the voltage V2 minus V1. Now we have here two linear equations. These are algebraic equations. And we can rewrite those equations using matrix representation. What I'm telling you is that we can define a vector, and that vector will be the current vector. And each element inside the current vector will be the individual currents I1 and I2. Similar approach is for the bus voltage. They can be inside a vector that is the voltage vector. And the components or elements inside that vector, V1 and V2. So finally, what is connecting the relationship between current and voltage is basically the admittance matrix. And if you look to that admittance matrix, voila, it's very, very simple, making a comparison element to element, and the conclusion is very simple. The conclusion is that comparing element by element, this admittance matrix is identical to the one formulated in the previous example. So as a consequence, all my students, they can understand that we can use circuit analysis, very basic circuit theory, in order to obtain the admittance matrix. Well, now there is a final step in this video. I hope you are enjoying the video because the final part is probably very, very exciting. Because the final part of this video is demonstrating that the numerical values that we calculate using the admittance matrix, those numerical values are properly correct. And to do so, what we are planning to do is using a commercial power system analysis software. As you must be aware, there are many power system analysis software. There are some commercial power system analysis software, there are some open access power system analysis software, and some of those software, they have the possibility of showing you the numerical values of the admittance matrix. That is not the case for every single power system analysis, but there is one that is extremely graphically friendly that allows you the access of the numerical values of this very important matrix. And that software is the very famous PowerWorld. In this video today, I will use this software, the PowerWorld, in order to show you the numerical results of the admittance matrix. PowerWorld is a commercial software. However, one very important information for you is that you can download for free what they call a demo version, a version that is for demonstration purposes. And that is what I will use today to show you. But before I go to the software, what I want to show you is here we have the numerical results, okay? If you look over here, this is a screen capture. This figure shows a screen capture of the numerical values obtained from the admittance matrix inside the software PowerWorld. To be honest, it's extremely simple to obtain those numerical values. If you download this file from my GitHub, this is the circuit, this is the power system that we are considering today in this example. What you need to do is import into the software, into the PowerWorld, and then you will go here to the room mode, case information, and solution details. And inside the solution details, you can obtain, as you can see over here, the admittance matrix. And the software will show you the 2x2 matrix representing the bus admittance matrix of this system. Just for evaluation, you can see here for simple inspection the numerical values for the main diagonal, minus 10J and minus 10J, they are 100% coincident with the values, numerical values that we calculate by hand, and also the elements outside the main diagonal. With this very specific and simple example, you can see that the numerical values that we obtained before, they are 100% matching and they are properly correct. Well, in order to finish this example, I will do this using the software PowerWorld, and I will show you here the software with the numerical results. Well, here we are inside the software, the commercial software, PowerWorld. In this case, this is the version 22 for evaluation. And as you can see over here, I already imported the file for the sample 1 admittance matrix. As you can see, there is the physical representation of the electrical power system, the single line diagram. There is a generator at the top, busbar number 1, one transmission line connecting between busbar 1 and 2, and there is a load over here. What I will do now is, well, you need to select here the remote, then go to case information, and when you arrive to case information, you can select here solution details. And the last option of this menu, as you can see over here, there is a Ybus. And you can see the selection is the admittance matrix. And here you can see the 2 by 2 matrix that is numerically equal to the values that we obtain using the hand calculations and using the circuit analysis. Well, this is a very basic video. In this video, what I try to do is to refresh the concepts about the power system representation using matrices. Today, we calculate the bus admittance matrix. In this case, using manual calculation, then we verify the results using circuit analysis, and we close this video using this amazing software, the PowerWorld, that allow me access to the admittance matrix in order to check my numerical results. And what is very, very important here is that we use our knowledge or equations in order to obtain numerical values, and then we use the tool, the software, for verifying all the results. My final message over here is that any power system analysis software is a calculator. And calculators, they can be used in order to demonstrate my ideas and to obtain numerical results. And today, those numerical results agree with my manual calculations. So in this way, I introduce the concept of matrix model that can be used for power system operation and economics. Well, this is all for this very interesting video today. I hope you enjoy. And if that is a possibility, please subscribe to the YouTube channel, leave a message, or simply drop an email, and I will be extremely happy to answer your question. Thank you very much, and this is all for today's video. Bye now.